Now we start with refraction. For that, you take a slab, glass slab. Like this is incident ray. It strikes here. This is normal. This is angle I, angle of incidence. Rare to denser, and therefore it bent towards normal. Strike the surface second. This is normal. Now this is air and surrounding this is also air. Therefore, the ray emerges out parallel, making now this is parallel to this is parallel to this. Therefore, this is transversal, and hence this angle R is equal to this angle, and this angle is equal to I, equal to this. So what happens? The ray passes from rare to denser, it bends towards normal, and as it passes from denser to rare, it moves away parallel to this. So this is called incident ray. This is refracted ray. This is called emergent ray. These are the two normals. अगर ये ग्लास शीट नहीं होती तो ये रे इंसिडेंट रे should have gone straight. What we see here, there is a change in the route. The amount of change has been this much, x. This is called lateral displacement. So this is all about refraction. And now we try to know the effect of refraction of light. Two cases may be considered. The first is a stick partly placed in water appears raised up. And second is an object placed at the bottom appears raised. We will discuss now the two cases. The first case is, let us consider a beaker filled with water. We put down a stick here, like this. This is the upper surface. This is normal. We take two rays. One is this, other is this. Then this is water and this is air. When the light rays moving from water to air means denser to rare, it bends away from the normal. It bends away from the normal like this. Like this. When produced back, meet at a point. So the stick now, when we see from here, appears to be bent like this. So a stick partly immersed in water appears to be bent. Second case is, when let us suppose this is a beaker filled with water. Here is a coin. When you see coin from here, it seems to be here. This is an object, a coin. This is perpendicular, normal. Let us take again two rays. This is water, air, denser to rare, it moves away and it moves further away. When produced back, both meet at a point. So this is the height raised up. And we see from here, the coin appears to be at this point. That means when we see from the rear side, the coin looks to be up by height h. Two kind of lens, convex and second is concave. Convex is like this, concave is like this. This is concavo-convex lens. And similarly, we can have many mixtures, many combinations, but only two are inner pores. Really, how are the images are formed? First, we take convex lens. When the object is at infinity, first case. This is pole, this is F, and this is C1, F1, and this is F2, C2. Let us take a ray coming parallel to principal axis, that means coming from infinity. Two rays. It strikes here and always passes through F. So pointer image is formed. So rays coming parallel to principal axis strike at some point on principal axis, what is called as focal point. So image formed is real and pointer. Second case, when the object is placed at a final distance. This is C1, this is F1, pole, F2, C2. Let this is an object. Again let us consider two rays. One is parallel to principal axis, it strikes here and always passes through F. And take another passing through pole. It meets here. So this is I, this is O. Object image formed. The rays that passes through pole never bend, it goes straight. And so the nature of the image formed is real, smaller and inverted. Other is third case. Now take another case when an object is placed F1 pole, F2, C2 at C. Let us take one of the rays parallel to principal axis. It passes through F. We take another one, passes through pole. So the image formed is here. The nature is real, equal and inverted. Next, we take another case. C1, F1, F2, C2. We put an object in between F and C. We take one of the parallel ray, round to pass through F. We take another one, pass it through F. It meets somewhere here. The image formed is real, larger and inverted. Next case. Let us take an object placed at F. Take one of them ray as parallel, allow to pass through F. Take another one which passes through pole, and what we see, it is always parallel. So image formed is real, larger and at infinity. Inverted, sorry. Larger, inverted. Next and the last. This is again very important. This is convex lens. This is C1, this is F1, this is F2, this is C2. I put an object here in between pole and F. So one of the rays is taking as parallel, allowed to pass through F, and another passes through F. When we see from here, it seems to be making its image here, which is virtual, erected and larger. When the image formed is on the opposite side where object is placed, image is said to be real, and when image formed is on the same side, we say virtual. We have lens formula. One upon F is equal to 1 upon V minus 1 upon U, where U is equal to distance of object from pole. V is distance of image from pole, and F is focal length. In fact, there are two focal points. Focal length is considered to be where to the opposite side of the